Okay, prove the sum of the squares of any three consecutive odd numbers is always 11 more than a multiple of 12. Okay, well, let's start with a odd number. So if we do 2n, that's even. So if I add 1 to it, it's odd. Okay, and we need the sum of three consecutive odd numbers, but they've got to be squared. So we squared that. The next odd number up from this would be 2n plus 3. There are different ways of doing this. You could have done 2n minus 1 in here, but it should all work out the same. And then the next odd number is 2n plus 5 squared. So we've got three consecutive odd numbers and we're squaring them. Okay, so let's actually expand this. 4n squared plus 4n plus 1 plus 4n squared plus, it's going to be 12n plus 9. This is where knowing your expansion of your double brackets is really helpful. Plus another 4n squared, then you've got 2 times 5 is 10, but you've got 2 of them, so 20n plus 25. Okay, it's got to be a multiple of 12 is always 11 more than a multiple of 12. So let's collect this together and see what we get. Well, we get 12n squared, that's looking promising. Then we've got 4n, 12n, and 20n, so that's 36n. We've got 1, 10 plus 35. Okay, well that's not a multiple of 12, but we don't want it to be because we've got this 11 at the end here. So let's split this. So we end up with 12n squared plus 36n plus 24 plus 11. So we're going to have our 11 more, and this actually is a multiple of 12. So if we factorise, we've got 12, shows it's a multiple of 12, n squared plus 3n plus 2 plus 11. Okay, so we've got a multiple of 12 plus 11. Always 11 more than a multiple of 12.